Development Program. I welcome today's resource person, Professor Kashilingam sir, Professor, Pondicherry University, to today's session.
Thank you, madam. Thank you. Shall we start? Shivakumar sir, shall we start, sir?
Yes, sir. Yes,
Yes,
sir.
sir.
Please.
Very good. So, Nandini, madam, ready? Oh, madam. So,
Ready, sir.
Yes, sir. Yes, sir. I'm ready.
Okay. So now, can you recall the different types of data, madam? What we have
Yes,
discussed?
sir.
yesterday?
Definitely, sir.
Please.
Nominal, ordinal, interval, ratio.
Very good. Very good. So now, what is nominal?
Nominal is namesake. For namesake, whatever the data we are going to enter, say, for example, in the
So
last
the
class. we had-
numbers are assigned without any logic, just like that we are giving,
Yes, sir.
right?
Yes, sir.
So
For
the
namesake.
example is gender, right?
Yes, sir.
Next.
Ordinal. Ordinal, sir.
Ah,
It is,
ordinal.
we need to follow the order, sir.
In the data, there is some order. In the
Yes, sir.
data, there is some order. In the data, there is some order. So, since there is order, when we assign according to that order, we are assigning the numbers. Okay, there is an order in the data.
Yes, sir.
Then interval.
Interval. It is a Likert scale system, sir. That is nothing but, equal distance will be there.
Okay, between numbers, there is a equal distance. Between numbers, there is a equal distance, right? Equal interval. So it is a rating scale. Yeah. Next. Okay, there is a order also. There is a order as well as the equal interval. Next.
Ratio.
Ratio. Yes. There is a order. There is distance. Apart from that, there is a zero origin. There is a zero origin, right? These are all the 4 types of data, right? 4 types of scaling or 4 types of data. Now, whatever the data you have, that can be brought under this 4. Whatever the data you have, that can be brought under this 4. So, your data can follow any one of these 4 types, whatever may be the data. Numbers, right? Then, we have seen for a nominal data, now we are looking at the univariate. What is univariate? We are if it is a nominal variable, what analysis can be done?
Frequency.
Frequency analysis, right? Frequency analysis. So what is frequency analysis? Counting how many ones are there, how many twos are there, like that, counting, right? So what is the analysis we have to do? If the column is ordinal data, if the variable is ordinal,
Again, frequency analysis.
frequency analysis, right? Very good. How to do frequency analysis?
We should go to
Analyze.
analysis, descriptive statistics, and
Very good.
frequency.
Yes, very good, right? So we can take one more friend. Can we take that Aksata madam, or you have some more friend, madam?
I have 2 friends
Manasa
today, sir.
madam.
One is Manasa ma'am, another one is Akshita madam.
One is Manasa madam.
Take Manasa, ma'am.
Let us take both, sir. Manasa ma'am and Akshita ma'am together.
Okay, very good. Okay, so let me welcome all for the interactions. Okay, okay. So now, okay. So all the data I already given to. Okay, so Shivakumar sir, he might have shared.
Al-
Okay.
Yes, sir. Already I have posted to WhatsApp. Everyone
Okay,
to
sir.
already asked to download also.
Okay. So now, okay. So now, liking. Okay. So liking. What is the type of variable, madam? Liking. This liking. Okay. Now liking. So it is a liking is 5-point scale. So it is a which variable? Which is a which type of data? Nandini madam, which type of data? This liking
That is, sorry. Which one, sir?
5-point scale.
Likert scale, no, sir. Frequency data is to be.
5-point scale is a which type of data? Hello?
Data is that is interval.
Interval,
Data.
interval, right. So it is a interval data, right? Interval data, here we have put a scale. So for interval data, what analysis you can do? Okay, so it is a 5-point scale. For a 5-point scale, okay, it is a 5-point scale, liking it is a 5-point scale data, which is a interval data. What analysis you can do for a interval data? Yes. What analysis you can do? So
We can do mean.
Madam Nandini madam, what analysis you can do? To the madam, all you can respond, right? What analysis you can do for a liking 5-point scale? Madam, tell something. Let it be wrong.
I don't know, sir, seriously.
Madam? Madam.
Mean, median, mode. Some of our friends are giving suggestion here in the chat box. Mean, ANOVA.
So now can we do frequency analysis, counting how many ones are there, how many twos are there?
No, sir.
Okay. So now, so you can do, now what will happen? Let us see. Okay, so if you, I can do, for example, let me do frequency analysis. Okay, so it will do. Okay, so now let me do and let me put it. Okay, so it will say 11 people are strongly disagree, 20 people are disagree, 8 people are neither agree, 11 people are agree, and 2 people are strongly agree out of 52 people. So it will tell like that. Now, for example, right, if somebody asks you, okay, so for example, you have done a survey in a mall. This project is done in a mall, right? If the owner asks the investigator, so you have done a survey among the people, what you have done? You might be telling that I have asked their satisfaction, sir. So if he asks what the people are telling, then if you say based on this one, if you say 11 people are strongly disagree, 20 people are disagree, 9 people are not, 11 people are agree, and 2 people are strongly agree, right? See, for example, the owner of the mall is asking a question, simple question. What question? Madam, you have done a survey, you have asked, you have done a survey among the customers. He is asking what the people are telling, simple question. So now you have decided to give answer based on this question. Okay, you have decided to give answer based on this question. Now you have collected 5-point scale. Okay, so now if you tell 11 people are strongly agree, 20 people are disagree, like that, 8 people are not, 11 people agree, 2 people strongly agree, he will get confused. What strongly disagree, non-da, all these things he is telling. So he may not understand. He may not understand. But you cannot give any other answer than this one based on frequency. Okay, you can tell this many people are agree, this many people are disagree. Only that answer you can tell, okay, if you have a frequency analysis. Right. Suppose if we have done a mean, now let me perform a mean and let us see, right? Descriptive statistics, frequency,
So please
liking.
share the screen.
Oh, share பண்ணல நேத்தோட அப்புறம் என்ன சார் பாத்தீங்க? ஐயோ சாரி சார்.
Share the screen.
I'll share. Okay, so all windows இருக்கு அதை click பண்ணுவாப்பா. That will be better, right?
Yes, sir. Your screen is visible now, sir.
Okay, so now let me do it again, sir. See, okay, so first itself. Okay, so now, okay, so let me do it again. Okay, see, for example, for liking, okay, liking. Okay, let me show you again. Liking is so liking is a 5-point scale. You can see 5-point scale. So analyze descriptive statistics, frequency, liking, right? First, let me do simple frequency, then you will get this answer. Strongly disagree 11, disagree 20, non-die 8, agree 11, strongly agree 2. That is the frequency analysis. Right. So suppose let me do the mean analysis, descriptive statistics. Frequency, liking. If I want to do mean, then I have to go to this statistics. Statistics. Then let me put mean. Let me put mean. Okay. Then let me put continue. Let me put okay. Then I will get to this mean, right? Okay. So now, madam, can you see the mean, madam?
Yes, sir. Yes, sir.
What is the mean value?
2.48, sir.
2.48. Now, what is the meaning of mean 2.48, madam?
Yes, sir.
Now you know the frequency analysis. So this many percentage. Now, what is the meaning of mean 2.48? Average, right? It is average.
Average.
So, okay, we are taken in a 5-point scale. We are taken in a 5-point scale.
Okay.
If the mean is less than 2.5, then we can tell people are disagree. Agreeing, which means they don't agree, which means they don't like. They don't like, that is the mean. If it is less than 2.5, which means they are disagreeing. Here they don't like, that is the meaning. If the mean value is more than 3.5, then they agree, which means they like the people. If it is between 2.5 and 3.5, so it is neutral. So they do not have much liking as well as disliking. They are okay with the people. Okay, so they cannot say people are good. They cannot say people are bad. So they have a neutral opinion about the people. So let me tell, if the mean value is less than 2.5, disagree. More than 3.5, agree. If it is between 2.5, 3.5, neutral. So then based on your statement, you have to give the interpretation. Now, that gentleman, the owner of the mall, he has asked what the people are telling. Now you can tell, sir, the customers are not liking the people of your mall, sir. If you tell this answer, then he will understand. He will understand. Okay, so now, see, you can use frequency analysis, nothing wrong. You can tell this many people are agree, this many people are disagree, this many people are nanda, nothing, okay, wrong. But, so coming to a conclusion, whether, see, our question is, we want to know whether people are liking or not. That is what we want to know. That is why we have put that question. Okay, do you like the people of this mall very much? So our idea behind that question is, we want to know whether people are liking or not. If you use the frequency analysis, we cannot come to that conclusion. But if you use mean, we can straight away come to a conclusion, right? See, for example, if I ask Nandini madam, what is your mark in PG? She can tell, okay, each subject, she can tell the marks, because I'm asked the question, what is your marks? She can tell the mark in individual subject. Then immediately I can come to a conclusion that Nandini madam is excellent madam, passed with the distinction. Right. So here the percentage is the mean average. Okay, 82 is the average, because all are in hundreds, 82 is average. So when you say average, it represents all. See, when she is telling 82 marks, it is the average of all the subject. It represents all. It represents all. So it is a one value which represents all, So we can come to a conclusion, right? So we can derive very easy conclusion when you use the mean. Madam, is it okay, madam?
Yes, sir.
Clear?
Yes, sir. It is clear, sir.
Very good. So now let me tell one more. See, for example, right? See, let me show one more there. See. See, now here I have one questionnaire. Here I have some construct, right? Here, for example, here. So this construct is about the workplace conditions, okay, which contains 13 statements, 5-point scale, 13 5-point scale. One construct with 13 items, 13 statements. So if I want to do analysis for this, if I do a frequency analysis, then I will get 13 tables. 13 tables.
Excuse me, sir.
Yes, madam.
Image is not visible, sir.
You can zoom it for 100%, sir. It is 13%.
Which is not visible, madam.
Whatever the
Yes, sir.
data you're showing, sir.
Sir, below you put 100%, sir.
Wait, sir. Wait, sir. So now what happened? They have introduced some new things. Now is it okay, madam?
Yes, sir. Yes, sir.
Okay. So now here I have one construct which is workplace conditions, which is having 13 items. Okay, 13 statements, all 5-point scale. You can see all 5-point scale, So then if you want to do analysis, then you have to do, it will give 13 tables. Then your thesis will be full of tables, right? Then this many for each statement, this many people agree, this many people strongly agree. People are doing. So this many people agree, this many people disagree. They will write, right? Then we cannot come to any conclusion, such as, for example, if you do a mean, what you can do for every statement, there will be some மேடம் நான் ஈவினிங் பேசுறேன் மேடம், ஒரு ஒர்க் ஷாப் எடுத்துக்கிட்டு இருக்கேன் மேடம். ஓகே, தேங்க். So now for each statement you will get a mean, right? Then what you can do is for each statement you can put a mean one. Okay, so one row like this. For each statement, what is the mean you can put? Then you can do, people are okay happy with this statement, people are happy with this statement, people are happy with this one, we can tell. Okay, one table itself we can show. Then apart from that, if you put a mean, you can find out for which statement people more happy, which people okay, for which statement people are more happy based on mean value, right? So if you do a mean for a 5-point scale, so you will be having many advantages. Number one advantage, we can give the conclusion easily, understandable conclusion. Then okay, when you have many statements in one construct, okay, all you can put it under one table. Then if you have a mean, you can compare one statement with another statement, you can give an opinion. So finally, for a 5-point scale or for a interval data, let us perform mean. Mean will give a better result. Okay, so that is what I want to communicate now. Madam, understood, madam?
Yes,
Clear?
sir.
Okay.
Yes, sir.
Okay, very good. So now let me go to the fourth one, right? Let me go to the fourth one, which is the ratio scale. Ratio scale. Okay, so which is the ratio scale? So income, right? What analysis you can do for this income, madam?
Ratio income.
What analysis I can do for the income?
Mean only, I think. Average.
Okay, average only.
Okay.
Okay, so now suppose, okay, now suppose if I perform frequency analysis, what result I will get? I will say 1% 10,000, probably 2 or 3 people 15,000, 25,000 2, 50,000 2, 65,001, 17,001, 12,002, like that you will tell. Yes or no, madam?
Yes, sir.
So now let me perform frequency analysis. Let us see. Right. So once you have clicked, it will be there automatically. So let me remove. So I'm just putting only frequency.
Sir,
Okay.
that screen is not visible right now. Workplace condition screen only visible, sir.
Yeah, multiple screen போட்டா அது வர மாட்டேங்குதுப்பா. ஏன்பா இப்போ ஷேர் பண்ணுவா. மேடம் விசிபிளா? Hello, madam.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Now it is visible.
Okay. So you have to interact with me often, madam. Huh?
Okay, sir.
Okay. So now let me put income. Okay, income. Okay, into variable. So here statistics. Okay. So already it will be whatever you have clicked, it will be there. I have removed, right? You have to remove this mean. So once you have clicked, till you close that data set, it will be there, whatever you have clicked, right? So
Okay.
now I have removed. Now let me say okay. So now let me go to the result. Result is visible, madam?
Yes, sir.
Yeah. So now here what happens? Okay. So 4,001, 10,006, 11,000. Okay, I think I put it wrongly. Sorry. instead of putting income only I put. Okay, income only. Sorry, right only, right. So now let us see the income. Okay, so 4,000, 10,000, 11,000, 12,000, 14,001, 15,009, 17,007, 20,004, 22,001, 25,008, like that it will give. So we cannot come to any conclusion. We cannot derive any meaning. Okay, now let me use the mean as madam has stated. Let me use a mean now. So statistics, where I have to go, madam? Mean? Madam, where I have to go?
Statistic mean.
Statistics. So now here mean, all right? Mean, continue.
Continue.
Okay, right. Now the average mean is what is the value, madam?
Okay, 24,980.77.
Very good. So 24,980. Okay, so that is the mean value, right? So what is the meaning of that, madam? What is the meaning of that?
Average
Average is
24,980. The
Okay.
average of income.
Yes, fine, madam. Average of that. Okay, so now what do you mean by average of that? So now see, whatever data you are collecting, whatever question you are putting, there should be some reason. Now, this is a mall question. You are asking the customer's opinion about the mall users. Why you are asking this income? Right. I'm asking the income to know the income of the customers. Why I should know the income of the customers? If I know the income of the customers, then the merchandise which I can use, the items, what I can store, right? Accordingly, I can decide. Here, the income of the customers on an average, it is 24,000 or 25,000, which means we can say it is a lower middle income people, not lower, not even middle income. Middle income is around 40,000 rupees. So now, okay, so it is lower middle income, or according to, you can say middle income people, like that. So accordingly only you have to make costly items. You cannot make arrangements in that. Okay, so from this we can understand the average income of the people is 25,000. So from this it is clear that the average income of the people is the customers are lower middle income people. Right. So now for a ratio data, mean is the solution. Mean is the we have to use only mean. If you use frequency analysis, you will end up in chaos. Right? You cannot use. Okay. So finally, there are 4 types of data. One is nominal, ordinal, interval, ratio. All right. What is that meaning of each one? Yesterday we have described why it is called ratio, why it is called interval, all we have described. Now, when you take only one data, otherwise only one column, right? When you take only one column, right? When you take only one column, univariate. If it is a nominal variable, you have to use frequency. If it is an ordinal variable, you have to use frequency. If it is an interval data, you have to use mean. If it is a ratio data, you have to use mean. Right? Madam, repeat,
Yes,
madam. Repeat, madam.
Yes, sir. There are 4 types of data which we discussed in the last class. One is nominal, ordinal, interval, and ratio. For that, each data having analysis part. For nominal, it is a frequency. For ordinal, frequency. interval mean as well as for ratio mean.
Okay, so this is for a univariate condition. That is only one variable when you take, right? So now, okay, I have to go for a bivariate. Normally I will not go beyond this one. Then I go because now today let us try to experiment something by teaching something more, right? Okay, so now let us see where how you are understanding. Easy only, right? Okay, madam, please come with me, right, madam? Okay, only again. Okay, so only the again univariate condition only we are going to discuss. Okay, so now let me take one ratio data. So before that, okay, so before that, before going further, let us check your understanding. Okay, let me check your understanding. Okay, so Aksada madam and then Nandini madam, all be ready, all be ready. Now you have to tell, I am going on questionnaire, you have to tell what is the type of data, right? Okay, very good, right? Yeah. So gender, what is the type of data, madam? Here, can you see
Data
questionnaire,
nominal.
madam? Madam, can you see questionnaire, madam?
Yes, sir. Yes,
Yeah.
sir. I can.
Yeah. What is gender?
Nominal. Sorry, gender means that is nominal, sir.
Nominal, right? Okay. Okay. So don't be hurry, madam. Okay. So relax and tell, right? Okay. Relax and tell, right? Next is age. What is this?
Ratio.
Ratio. Very good. Ratio. Very good. Educational qualification.
Education qualification means interval.
திருப்ப சொல்லுங்க.
Sorry, ordinal.
Hello, educational qualification.
Ordinal, sir.
Madam, நம்ம example we have taken only ordinal, right? Right, very good. Marital status?
That is nominal.
Nominal. Family size?
Family size. Nominal.
மேடம் உங்களுக்கு புரிஞ்சது மாதிரி எனக்கு தெரியல மேடம்.
Sir.
Okay. Aksada madam, all other people are there. Please respond. Madam, the family size, for example, you are having 6.
Okay.
Some people are having 4.
Okay.
So we can tell they are having bigger size family. 6 people mean? Yes or no?
Yes, sir.
So which means there is order. How can you say nominal?
Okay.
Nominal means number will not tell anything, madam.
Okay, sir.
Now the family size is not nominal, it is ratio. It is ratio, madam. Okay. So now, okay. So now, madam, carefully, please tell, madam, please understand carefully. Okay. So mother tongue.
Mother tongue. This
Nominal.
Mother tongue is nominal. Now, please understand. See, normally, if there is a dash, we will say it is ratio, right? Yes or no? See, for example, age ratio, family size ratio, here monthly income ratio, all ratio, if it is dash. But here, see, mother tongue dash we have given. But what they will write? They will write Hindi, Malayalam, Telugu, like that. For which we will assign numbers. That numbers will not have any meaning, which means it is nominal.
Okay.
Yes, madam?
Yes, sir.
Right. So that distance?
Distance interval.
Yo, madam.
Sorry. Workplace to place to ratio, sir. Ratio.
Ayyo, pochra.
Wrong, sir.
Yeah, wrong only, madam. It is ordinal. See, for example, why it is called in a less than 1 kilometers, 1 to 3, where is interval, equal interval? More than 5 means even 10 years. Yes or no, madam? Hello?
Yes. Yes, sir. Yes, sir.
Okay, so it is ordinal only. So now monthly income,
Income ratio, sir.
eighteenth question, how do you spend your remittances?
Mm,
And no answer.
Nominal.
அவ்வளவு கஷ்டப்படுத்துதே. It is nominal, madam. It is nominal.
Okay, sir.
Okay. It is nominal. This is very, very vital. Without knowing this one, you cannot do any analysis. This is very, very vital. When you look at any of the question, you should be in a position to tell whether it is nominal, ordinal, interval ratio. That is point number 1. Point number 2, see, for example, when some people, they bring a data to me, they may not bring the questionnaire. By looking at the data, we have to tell whether it is a nominal, ordinal, interval ratio. Okay. So very good. Okay. So madam is having little difficulty. Very good. So now, okay, now let us open to all, madam. Any questions in understanding nominal, ordinal, interval ratio? Anybody can, they can raise the hand and, okay. Hello?
Yes, sir. Anita madam and Sangeeta madam is raising their hand.
Okay, so ask them one by one, madam. One.
Yes, sir. Okay. First, Anita ma'am. You can unmute yourself. This one.
Yes,
Sir, good
madam.
evening, sir. So occupation is nominal, am I right, sir? Occupation.
Where is occupation, madam?
No, I just want to clarify, sir. It's not here. Just I want to clarify. If I have a question based on occupation in my
No,
question.
madam. See, occupation is which one?
Occupation, sir.
Yeah, I understood, madam. Is it is a nominal or ordinal?
Nominal. Is it nominal?
It is nominal, madam. Pakka.
Oh.
It is nominal. See, for example, somebody agriculture, somebody businessman, somebody private employment.
Yes,
We cannot
yes,
tell that is big one, that is small one. We cannot tell.
Yes.
Hmm.
Okay, sir. Thank you so much, sir.
Next.
Sangeeta ma'am.
Sir, good evening, sir.
Good evening, madam.
Sir, when you explain the mean justification, less than 2.5 people are disagree. So greater than 3.5 people are liking or agree, sir. So could you give any more example, one more example for understanding the mean justification, sir?
Yeah. Even if I tell again, I have to tell the same thing, no, madam. See,
Okay,
for
sir.
example, any 5-point scale, madam. Any 5-point scale.
Okay.
Right. Any 5-point scale. Right. Any 5-point scale. For example, you talked about the awareness, right? Do you aware? So if it is less than 2.5, which means they don't aware. If it is more than 3.5, which means they aware. Right.
Okay.
So you put a 5-point scale in awareness, right? You have put excellent, all these things, 5-point scale. So you have put knowledge. Okay. So level of knowledge, level of understanding, level of awareness, whatever it is. From low to high, right? 1 is low, 5 is high. That is the meaning, right? When you put 1 is low, 5 is high, then if the mean is less than 2.5, which means low awareness, low understanding, low score, right? That is the meaning.
Okay, sir.
Clear,
Okay, sir.
madam?
Thank you, sir. Clear, sir. Clear, sir. Thank you.
Okay, okay.
Anupama ma'am.
Yes,
Good evening, sir.
yes,
Sir,
madam.
actually, you can explain the ratio scale once again.
That is it asked yesterday, no, madam.
Sir, there is a little doubt between interval and ratio scale.
No, madam. In a ratio, there is a zero meaning. What do you mean by zero meaning? See, for example, okay, yesterday I spent a lot of time on that, madam. See, for example, in an interval scale, that is the 5-point scale, you can start with 1, or you can start with 0, or you can start with -2. Right. See, for example, when you 5-point scale, you are giving numbers. So when you start with the 0, which means 0 is not zero meaning. It is the first level, that is the meaning. Right. If we have put the -2 to +2, the 0 in between, it is not the 0. It
Excuse me, sir. Sir,
Wait, network problem.
okay, sir.
Sir will join. Kashilingam, sir.
hello, hello, madam.
Hello, sir. Hello, sir.
Meanwhile, I have lost the connection. I was going on discussing, right? Okay.
Welcome back, sir. Welcome back, sir.
Understood, madam.
No,
Okay,
sir.
so
No, sir.
till what level you are there? Hello, madam.
Yes, sir.
Shall I tell again, or you have understood, madam?
Please tell again, sir.
Madam, what till what level you are there, madam?
I think I'm in 60, sir.
Hello?
60%.
No, I'm not asking about percentage. So I was discussing for quite some time, right?
Okay.
So I was
He
making
was
many
explaining.
till which statement you are there.
Okay, that is a zero meaning. We are explaining one.
That's all. No, that is the only difference. The difference is in an interval scale, 0 is not having a zero meaning. Right? Zero means it is one level. There is a levels. Right? 0 is not having a meaning there in an interval data. For a ratio data, 0 is having a meaning. Which meaning? Zero meaning. Okay, zero meaning means nothing. 0 means nothing, right? See, for example, okay, so let me ask one question. Number of children you have. Tell number of children you have. Some people they have put to 0. Some people they have put 1, 2. Right. So now, see what is the meaning 0 there? 0 means she is not having any children. That is the meaning. Right. So in the interval scale, you cannot have like that. Interval scale in a 5-point scale, right? So let us assume that, okay, strongly disagree, you have put -2. Disagree, you have put -1. For neutral, you have put 0. All right. So here the 0 means he is not having a like opinion like that. He is having a better opinion than disagree. That is the meaning. Next level. Understood, madam?
Sir.
Hello?
Yes, sir. Yes, sir.
Okay. So don't worry, madam. Don't worry. Very simple only. 0 origin. That's all. Nothing more than that. Okay. Okay. So now the many hands I could see still. Okay. So now we will stop. We'll go next. Okay. So now, okay. So if I show any data, people should give the answer, right? Okay. Very good. Now we will discuss something more. Okay. So what I'm going to discuss is I'm going to take one ratio data, right? One ratio data. I'm going to describe something more, right? So now I have a age of the employer. Okay, so I have collected a survey from the employer of migrant laborers. So now can you see one data, madam? Can you see?
No, sir.
No, what?
No.
So that, yes, sir. Yes, yes, age of the employer. Please click on that.
It is there, no?
Sir, it is not.
Yes, sir. Yes, sir. Visible.
Madam says not visible, sir.
Sir, now it is visible that social economic background is visible, sir. Social.
No, social. Now can you see age or not?
Yes, now it is visible. Age of
Okay.
employer.
Right, very good. So now, what is this data, madam? Age.
Age.
What is this data among the 4?
Among the 4, age is ratio.
It is a ratio, right? It is a ratio. So that is why we have put here. So scale, right? We have put the scale, right? Very good. So now I have a one ratio data. Age, right? 52. The first person is having age of 52. Another person, second person is having age of 41. So the first person is having higher age than, so that is order like that we can see. Now for a ratio data, I can use mean, right? I can use mean, right? So let me use a mean. So I'm going to teach some more, right? So now analyze descriptive statistics. Madam, tell what statistics?
Descriptive statistic, frequency.
Descriptive statistics means describing, right? Describing. For if you have one data, we are going to describe that data. Now, descriptive statistics contains, right, 4 things. One is frequency, leave alone the frequency. Next 3. Number 1, measures of central tendency, measures of dispersion, measures of distribution. Right, measures of central tendency, measures of dispersion, and measures of distribution. For one data, we can use all. The measures of central tendency is a mean. We can find out mean for that data. Measures of dispersion, how the data disperse. Okay, how it is dispersed, right? How that deviation, how the spread of the data. Distribution, how it is distributed, right? We can find out three things. One is central tendency. Madam Cholunga, measures of central tendency.
Measures of central tendency and dispersion and distribution.
Dispersion, measures of dispersion, deviation, right? Then distribution, right? Okay. So these three you have to, okay, three things available. So we will try to understand, okay, so one by one. Under measures of central tendency, we have 5: mean, median, mode, harmonic mean, and geometric mean. Here, let us not use the geometric mean, harmonic mean. We will try to understand mean, median, mode, right? So you know mean, right? So adding all, dividing by number, that number, right? That is called the mean. Okay. So what is mode? What is median? I'm going to explain now. All right. So this is age of the employer, statistics, right? So I'm going to use the mean, median, and mode. And measures of central tendency you can see. Measures of central tendency you can see. These three you can find out. All right. So now continue. Okay. Now mean is 42, median is 42. All right. What is the mean? You know. What is median? Median is 50%. Median, middle, 50%, right? Now, so median is 42. Now see here. See, now you can see the frequency. Madam, table is visible?
Yes, sir, it is visible.
Okay. So now look at the percentage for 26 two people. So 1.1 because it is collected from 180 people, right? 180 people. So 182 out of 180, 1.1. So 28 is 1%. So 0.6. So this is the cumulative. So 26 two people, 28 one people. So 3 people out of 180, it is 1.7, right? Added cumulative. Now if we go to 42, you can see the 52, right? 57 people are there. 57.8% of the people, they have age less than 42. Okay, so where the 50% of the people coming, right? So 50% of the people have age less than 42. That we can tell, right? So now, in fact, not only 50%, 57 point, it should be not less than that. It should be more, right? So minimum 50% of the people less than that, right? So now I can tell 57.8% of the people have age 42 and less, right? So if you put 41, only 48%, right? Only when you cross for 41, 42, only the 50% is lying. So that is why median is 52. Median is middle, 50%. Where, in which age the 50% is coming? That is the median. That is the median, center median, middle, right? Mean is average. Next is the mode. Now let us look at the mode. Mode is 45. So what do you mean by mode 45? Where there is a maximum number of people. So which number occur more number of times? Or which age more number of people are there? So now it is 45. Now let us go and see. So 45, 23 people. Okay, so that is 12.8% of the people have 45. If you look at 40, only 19, 42, 60. Okay, so only 45, 23 people, which means 45 occurring more number of times. So the mode is which number occur more number of times, that is the mode, right? Median is where 50%, then mode is, okay, which number occurring mode, that is called mode. So for one data, we are describing, right? So this is the median for this data, this is the mode, okay, like that. Okay, so now, right, I'm going to tell one more, right? Analyze, madam, understood, madam?
Yes, sir. Yes, sir.
Okay. Descriptive statistics, frequency. In the statistics, I'm going to use this percentile, right? Percentile, right? Percentile, right? I'm going to use this percentile. Let me put quartiles. Let me put quartiles. Okay, not percentile, quartiles. I'm using quartiles. Okay, first quartile, second quartile, third quartile, right? So quartile, 4 quarters, right? 100, 25 is the first quartile, 50 is the second quartile. Okay, tomorrow morning. 75 is the third quartile, right? 25, 50, 75, right? Okay, fine. Now, okay, so 25, 50, 25 is the first quartile, 50 is the second quartile, 75 is the third quartile. Okay, otherwise 25% of the people, where to the 25% of the people are coming, that is the first quartile. So when you divide the people, 100, so many people, so 25% of the people will be within this age, 50% of the people within this age, 75% of the people within this age. Okay, when you divide all, so arranged in a descending order, median, how it is called? It is arranged in ascending order, descending order, then it is calculated where 24% is coming. So now the first quartile is 25%, second quartile is 50, right? So now what is second quartile, madam? Can you give another meaning for another name for second quartile?
Another name.
We can also call the second quartile as
Median, sir. Median.
Median. Very good.
Oh.
We can call, okay. Sivakumar sir, you are there? Very good, sir. So now see here, 25% is 35.25, 50 is 42, right? So 75 is 46. It should cross 75. Okay, that is the meaning, right? So now you can see 25. Okay, so 25% is 35.25. 35.25. Now, see, look at this one. So 35 is only 25 is coming. That is why it is giving something more. When you go to the 35.25, then you will be crossing that 25, right? See here, 35 is exactly 25. So that is why it says 35 something, then only 25 below that 25% of the people are there, you can tell. So now 50% of the people we have already seen 42 median and 42, right? So we can see then 75% of the people 46.75. Now let us see, right? 46 is 75. So that is why it has put 46.75, right? 75 because it is exactly for 75%. So it should cross, right? So quartile means 25% of the people, less than that. Quartile one, second quartile is 50%, third quartile is 75%, right? So now that is the meaning, right? Very good. Now we have understood the measures of central tendency, right? We have understood the measures of central tendency. Now let us go to the measures of dispersion. How data disperse. Now the range, right? See here, when you look at this one, the data is distributed from 26 to 60. So that dispersion, how it is dispersed. So now, okay. So now for to measure the dispersion, we have many. One is called the range. Another is called the mean deviation. Another is called the standard deviation, right? So, and another is quartile deviation, right? Like that we have. But here we are going to have, okay, only only few things, right? So statistics, okay. So now we will remove all these things, okay. Let it be there. Okay, we can see the standard deviation and the range, right? So now these two we will try to understand, right? Minimum and the maximum also we will see. Minimum, maximum, minimum. The variance also we will click, right? Okay. Okay. So now the range. What is range is the difference between minimum and maximum. Okay, the age is distributed between, here minimum is 26, maximum is 60. So the range is 34 years of age, okay, in between minimum and maximum, right? So this much difference is there. One person is 60, another person is 26. So 60 minus 26, the range is 34. The range is 34. Right. So now, what is the standard deviation? Right. See, many people, they use standard deviation in the thesis, but they are not writing the meaning for standard deviation. Right. So now we will try to understand what is standard deviation. Right. We will try to understand what is standard deviation. Right. Okay. So now one example, madam, PPT is visible, madam?
Same frequency analysis is showing, sir.
Okay. This PPT is not visible, huh?
No.
Okay. So now I hope it will be visible to you.
Yes, sir.
Madam, okay. So now standard deviation, right? Now, right. So let us assume there is only two data. There is only two data. 9 and 11. What is the mean for the data, madam? 9 and 11. Madam?
Sir.
What is the mean for 9 and 11? No, madam, average of 9 and 11, madam. Hello?
10.
10, right. Okay. Now, 10 is the average, right? Now, what is standard deviation is the deviation from the mean, right? Deviation from the mean, right? That is the standard deviation. Okay, standard deviation. How the data is deviating from the mean, right? So for you will be having many data, right? You will be having hundred thousands of data. So there will be only one mean. Each data, there will be some deviation, right? So here there are two data, there will be two deviations. So we want to find out the average deviation, right? So now here, what is the average deviation from the mean, madam? Hello, madam. What is the deviation first data, madam? 1, right? Hello?
Yes, sir.
Now, see the mean. See what is standard deviation is deviation from the mean, madam. Understood?
Okay.
Understood or not, madam? Deviation from the mean. See, now you have one data, madam. One data, right? For any data, you will have mean, right? So, for example, each data for here, there are 9 and 10, 11. Mean is 10. So now what is the deviation? 1, right? The 9 deviation from 10 is 1. Okay, 11. What is the deviation from the mean? 1. Right? There are so which means the average deviation is 1. So the standard deviation is 1. So by just looking into the data, we can tell the deviation is 1. Hello?
Yes, sir.
Okay, very good. Now, right, I will be talking about more mathematics, madam. Please be okay. So, very easy only, nothing difficult. Now, what is the formula for standard deviation? Right, we say the deviation, right? The deviation from the mean, which means x, the data, minus x bar, that is the mean. 9 minus 10, that is the mean, right? So now to find out the average, we have to divide by n. The n, it is there. So x minus x bar divided by n, that is summation divided by n. We should put that should be the formula, right? Each deviation, summation, average. But if I put, see, let us use this one, right? If the formula is summation of x minus x bar divided by n, now what will happen? Now first data is 9, mean is 10. 9 minus 10 is minus 1. Next is 11. 11 minus 10 is 1. If you do summation, minus 1 and plus 1, it will be 0. Madam, is it okay?
Okay, sir.
Madam, sound keela bode, puriyala pola irukku.
Yes, sir.
Enna puriyala, madam? What you don't understand? Hello, madam, enna puriyala? What you don't understand, madam?
Sir, I'm listening, sir.
Madam, x minus x bar, that you understood that?
Yes, sir.
X bar is 10, understood that?
Yes, sir.
X is 9, x is a variable, right? X is a variable, right?
Okay.
So it will take many values. Here the values are 9 and 11.
Okay, sir.
Clear?
Yes, sir.
So this is x. Madam, நீங்க எப்படி பண்றீங்க? Okay, so x minus x bar. So 9 minus 10. What is 9 minus 10?
9 minus 10 is minus 1.
Minus 1. 11 minus 10?
1.
Okay. So how will you find out average, madam? How will you find out average?
Divided by n.
Adding those numbers divided by n.
Yes, sir.
Right. So now that is the deviation. See, this is the deviation from the mean. Okay, we are trying to find out average deviation. Okay, so add minus 1 and plus 1, madam. Minus 1 and plus 1, what, madam? Hey, -1 and +1. What is if you
Zero,
add
zero,
what?
zero, zero,
Zero,
zero.
sir.
Zero, zero, sir.
Zero.
Zero, sir.
Okay. So now the summation of x minus x bar, it will be 0 always. Because why it is 0? Because we are taking the central value. Some values will be this side, some values. So what is mean central value? That mean average. Okay. So some values will be this side, some value will be this side. Right. So the minus some equal, there will be equal minus and equal plus. So when you add, it will be 0. So the actually standard deviation is deviation from the mean. But what will happen since we take x bar, it will be 0. So to avoid that 0, we are taking the square, right? So the x minus x bar square, -1 square, madam, -1 square. Madam, what is -1 square, madam?
+1.
Okay, +1 square.
1.
Okay. So now when you take a square, the minus will become plus. Okay, that is why it is becoming plus. Now if you add, it is 2.
Okay.
Now it is 2. So now let us put into the formula. What is the formula? Okay, so now so that is we have taken a square, right? So now the summation is 2. 2 divided by number of cases 2, which is equal to 1. Right. So now see what happens. See, we want only the actual deviation, but to avoid 0, we have put a square. We have put a square. We have to remove that square. So we are taking square root. So square root of 1, which is equal to 1. So the answer is same 1. Understood or not understood, madam? Okay. So if you don't understand, leave it, madam. Okay, so this is very simple mathematics only, leave it. Now, okay, now what I want to tell is, see, for example, let us take some more data. Some more data. So like this, some more example. See, for example, one person, right? One person, he is taking the one subject 60 marks, another subject 50 marks, another subject 70 marks. So the mean will be 60. The standard deviation is 10. Right. Deviation, the mean is 60. The deviation from the mean is 10. Okay, mean is 60. So 50 and 70. All right. Okay. So 60 is the mean. Deviation is this side 10, this side 10. So deviation is 10. Right. So now look at the another data, another person, right? So he has scored 60, in another subject 40, another subject 80. Now what is the mean? Mean is 60, but the deviation, mean is 60, right? One subject 40, another subject 80. So the deviation is 20. So the standard deviation is 20. Right. So now how to infer the standard deviation? Now here look at this boy. He is taking 50, 60, 70. But look at this boy. 60, 40, 80. He is scoring 80 in one subject. Very good score. But he has failed in another subject. Right. So now which person you like? You like the first person. Because he is consistent. There is no deviation in his behavior. So we will say he is a good boy. Right. So now if you look at the mean, we cannot find out the dispersion. How he deviates, where he will go, right? That understanding we will not get it. That is why for every data, we will put the standard deviation also. When you have a standard deviation, how data dispersed, how it is moving away from the mean. For example, right? See, when you take investment, the mean return, one person is getting a mean one share, for example, fixed deposit. You are getting 6% deposit interest, always 6%, which means no deviation, no standard deviation. But the shares, it will give sometimes minus return, sometimes 20% return. Right? So that is why people are not going for equity. Why? Though it is giving 20 sometimes, but it is giving minus also, people feel it is risky. So that standard deviation is the measure of risk. Right. So by looking at the standard deviation, we can understand how the data disperse. When there is a more dispersion, so that the data is changing more frequently. Variability is more. The variability is more. The variance is more. Okay. So now, for example, okay. So many times, for example, we are going for a cultivation. We want to have less deviation. Right. So for students, we want to have less deviation. Even our behavior, that should not be easy. For example, okay, so one husband, we cannot depend upon this fellow. One wife will tell. Why? Sometimes he will show more love and love. Sometimes he will beat. Dangerous man. We are telling. Why? Because the deviation in the behavior. So not only mean, when you look at the standard deviation, we can tell how it will move, whether it is dangerous, whether it is good, okay, whether it is consistent. So all these things we can tell by looking at the standard deviation, the spread, the deviation. So when there is more deviation, that data changes, the opinion changes. Right. So the person is having, some people they have strongly agree also, some people they have strongly disagree also, when there is a deviation. Right. So when there is more and more deviation, so some people are strongly disagree. Right. So then we will be worried. So because we do not want to have any person strongly disagree. Okay. So there is a possibility people are having disagree also. So when you have more standard deviation. Madam, understood, madam?
Yes, sir.
Okay. So now see, only you are responding. Other two people, what happened, madam? Shivakumar sir, are you understanding, sir? Shivakumar sir, understood, sir?
Yes, sir. Yes, sir.
Okay. So that standard deviation is the most important measure we will be using. What is the interpretation you need to write? Okay. So the spread is more or the deviation is more. Okay. So there is a chance of strongly disagree also more. If see, for example, if the mean is 1, okay, mean is 1, 3, right? So which means a neutral. Okay. So when the standard deviation is 1.5. So which means that people are around neutral if the standard deviation is 0.5. If the standard deviation is 1, so which means some people are disagree also. Some people are agree also. So that is why deviation is 1. Okay, how? It will go away from the mean. Okay. So that is what you need to understand. Right, very good. So now, okay, I thought of telling population, standard deviation, all these things. Okay, so, okay, but, okay. Now, so I'm going to, okay, so I have to tell something more. Okay, that I will tell. But we will try to understand this box plot. Okay, so what is this box plot? Okay, what it tells? Box plot. Okay, so this box plot, let me draw this box plot. Automatically also it will come, right? Let me draw this box plot. Okay, so now what is the use of it? Okay, so we will try to understand. Okay, so same age. Okay, graphs, chart builder. Okay, so now I'm going to use the what chart I'm going to use. So any see, I have to see here the box plot. Okay. So let me take up. Okay, so now okay, so now I have this so box plot. So let me take this box plot and let me put it here. Okay. So now the age of the employer on the so oh sorry. So now, so I want to put the here it is. So yes, so things are there. Okay, so so now I have to click OK. Let us see. Okay, so OK is not visible. Okay, so now I have. So this is the box plot, right? So now you have this box plot, right? So now what is this? It is having some lines. Now you will understand. Okay. So now, since we have learned something, you will understand. All right. So now here one line, here, right? Okay. So now, first, what is this bottom line? Okay. What is this bottom line? So that is the equivalent to what? So equivalent to approximately equivalent to some 26, something like that. So now, okay, so now, so that is the minimum age is 26. So bottom whisker, this is otherwise called a whisker plot. This is otherwise called whisker plot or box plot. The bottom whisker, okay, tail, okay, it represents the minimum value. Then upper, it is 60. Now, because now you can understand all. Now the upper is 60. The upper line is 60, right? Okay. So now we have some more. What is that? Some more is, so we have, okay, first quartile, 35.25. Median quartile is 42. Third quartile is 46. 35, 42, 46. Now you can see that. Now 42 is the median, otherwise second quartile. This is the third quartile. Third quartile is what? 46. Okay, 46. This is the third quartile. This is the maximum. This is the third quartile. And this is the, okay, so, okay, so first quartile. So first quartile is, okay, so what is first quartile? First quartile is 35.25, right? 35.25. So now Okay, now we know all, right? So this is the lower value. This is the middle value. And this is the first quartile. This is the third quartile. This is the second quartile or the middle value or median value. So this is the third quartile. Madam, is it okay?
Yes, sir.
Madam?
Yes, sir. Is it okay, sir?
Okay. So now how to draw? Very, very simple. Okay.
Go to graph.
So graph.
Chart
Okay.
builder.
Graph. Chart builder. That
Okay.
box plot you have to select. The first box plot you have to track it and you have to put it on the top. The variable you have to put it on the y-axis. Automatically it will come. Automatically it will come. So now this is the box plot. Now what is the use of it? What is the use of it? So now before understanding the use of it, we will try to understand, okay, distribution, right? So we are seeing the measures of central tendency. We have seen measures of dispersion. Now we will see measures of distribution, right?
Measures of distribution.
Distribution. Okay, distribution, right? So we will take this itself. Okay, then we will go to the other one, right? We will take the same data, then one more data also we will use, right? So now analyze descriptive statistics, frequency, right? Statistics. So distribution is skewness and kurtosis. Skewness and kurtosis. Right? Okay. So now please remember. So what all things I have clicked? Mean, median, mode. See what all things I have clicked, right? So this one and quartile. And I have just clicked the skewness and kurtosis. Right? Okay. So now let us see what is the result I am getting. Now I see mean, I have clicked. Okay, so this is the 180 people are there, no missing value. Mean is 42, median is 42, mode is this much, standard deviation is 7, the variance is square of standard deviation is this one, right? So the skewness is 0.307. 0.307. Now kurtosis is minus or otherwise of 0.491. Range, minimum, maximum, all are clicked. So that is why I'm getting. Now, okay, you need to understand. See, please, I have not clicked the standard error of skewness. It is coming automatically. I have clicked only kurtosis, but it is giving standard error of kurtosis. Standard error of kurtosis. Why it is giving? Why it is giving? What is the use of it? Now, by looking at the skewness and kurtosis, we can find out whether the data is normally distributed. How dispersed, that is dispersion, how moving away from the mean, how the data is moving away, spread. Now, distribution, how it is distributed, right? Whether there is a skewness or kurtosis, right? So when there is, okay, so based on that, we can decide whether there is a normal distribution, whether the data is normally distributed or not. Now, many people, they will say the skewness is 0.307, which is less than +1 and -1, which means there is no skewness, which means the data is normally distributed. They will tell. They are wrong. No book can tell like that. They can tell the skew. See, when there is no skewness, when the skewness is 0. Right. Okay, when the skewness is 0. but see, we are going to see many hypothesis testing. Okay, so when we say there is no correlation, then which means correlation should be R value should be 0, but it will not be 0. There will be small value will be there. Okay, so whenever we say there is no difference, there will be some t value, but the t value will be less than, if the t value is less than 1.96, then we presume that difference is not big difference. Okay, so we have to look at that value, right? So we need to know whether the value is significant or not. For example, when in a t, we say 1.96, right? Okay, so that difference, right? So now we have to look at the value, whether it is less than that. Okay, we have to look at it. Okay, how to derive the t value? What is t value or is that value? The t value is nothing but, or z value is nothing but that measure. Okay, measure. What is measure? For example, if it is a difference, a t-test, the difference between two groups, difference in the mean. Okay, if it is a regression, the beta, the measure. Okay, now here we are measuring this skewness, right? So any measure, whatever we measure, that measure divided by standard error, that is the t value. Any measure, whether it, when it is a t-test, the difference, whether it is a regression, it is a beta. Here skewness, right? Here the skewness, right? That is what we are measuring, right? Skewness divided. That is why it is giving standard error automatically, because you will be interested. It knows that you will be interested to see. Okay, by just looking at the skewness, we cannot come to any conclusion. Okay, so we need to find out the z value, then only we can find out whether there is a skewness or not. So now the skewness, which is 3.307, the standard error is 0.181. 0.181. The skewness divided by standard error. Okay, so I have a calculated value, right? I have a calculated value. Okay, so is that value of skewness is equal to coefficient of skewness divided by standard error. That is the formula. So here 0.307 divided by 0.181, which is equal to 1.696, which is less than 1.96, which means there is no skewness. Okay, so what is the null hypothesis? Okay, what is the null hypothesis? There is no skewness, because we are measuring the skewness. So the null hypothesis is there is no skewness. We want to see whether there is a skewness. So the null hypothesis, there is no skewness, right? So when the z calculated value, right, z value is less than the threshold value of 1.96, right? Here, okay, so here you need to understand. Okay, so now I will show. Okay, so now, okay, I can write down. Okay, so otherwise I will show. Okay, very good. So now, okay, now, madam, is it visible? Some PPT? Critical value.
Normality slide is visible, sir.
So whenever I open new for data, so that is not visible, madam. So whenever I open anything new, that is not. So now I understand. Madam, now can you see some critical values?
Yes, sir.
So now, okay, so normally I will tell later, but now itself I will tell because you need to understand that. Now, the don't look at the third column, look at the first column and the second column. The first column is talking about the t value or z value. The second column is talking about the significant value, right? See, now, okay, now what you understand, madam? What you understand? What you understand from by looking at those two columns? Madam, tell. Hello? Madam?
Yes, sir. Yes, sir. I am here, sir. I am here.
What you understand by looking at the first two columns, madam?
That is t value is 1.64.
Don't read, madam. What you understand?
Okay.
What you understand? What you infer? Can you understand something?
Yes, the significant is less than 0.5. Sorry. No, sir.
See, see many things I have learned by looking at the output, right? I never read any book. Normally, my scholars will read. I will not read it. By looking at the okay, so table itself, we can understand.
Okay.
So that capability we need to develop, right? So now very clear. See, when the t value is increasing, the significant value is decreasing. Yes or no, madam?
Yes, sir.
Okay. Now, normally, we will have one rule. What is the rule? When the significant value is less than 0.05, we will reject the null hypothesis, right? So now itself you can write down. Otherwise, I will tell again many times. When the significant value is less than 0.05, we have to reject the null hypothesis. H naught. Right. Now you have to tell, see, I'm telling no, when the significant value is less than 0.05, reject the null hypothesis. Now you have to tell the same statement by looking at the t value. Now tell, madam. Hello?
Yes, sir. I am here, sir.
You cannot tell that?
Shiv Kumar, sir, will tell.
Sir, if the t value is 2.58, if the
No, wait, sir, wait,
than 0.01.
Sir, wait, sir. Sir, okay, so please
Okay,
see,
sir.
sir, what I am making is, when the significant value is less than 0.05, I say we are rejecting the null hypothesis. Now you tell, sir.
Sir, when significant value is less than the 0.05, reject the null hypothesis, accept the alternative hypothesis.
Sir, don't talk too much, sir. Okay, whatever I am telling, you tell the same statement, sir. Who you are going for alternate, who you are going for other things. See, I am telling, when the significant value is less than 0.05, see, first statement what I have made, by looking at this data, when the significant value is increasing, when the significant value is decreasing, my t value is increasing. Am I right?
Yes, sir.
Yes, sir.
Yeah. So that is the first statement I have made. Now I am making another statement. When the significant value is less than 0.05, I am going to reject the null hypothesis. Now you tell the same statement by looking at the t value.
So when t value is increased to 2.58, significant, that is also, reject one, sir.
Wait, no, madam, no. Okay. So now no, madam. So very simple. When the t value is more than 1.96, then we will reject the null hypothesis. Is it clear now?
Yes, sir.
Now, why you are going for 2.58? Why you are going for other things? I don't understand. So when I am telling 0.05, you have to look at the same value, same t value, right? See, I'm telling based on this one. Then when I ask you to tell based on t value, you have to tell only 1.96. So why are you going for 2.58, 1.64? Not necessary. Okay, so now the first statement, when the significant value is decreasing, it is increasing. So when it is significant value is less than 0.05, reject the null hypothesis. Otherwise, when the t value is more than 1.96, reject the null hypothesis. Right. So when it is more than 1.96, then we will reject the null hypothesis. Right. Madam, is it okay? Please write it down.
Yes, sir.
Everybody, please write it down. Write it down, right? Okay. Very, very simple. If you struck with something, you will not understand.
Okay.
Okay. So now let me go to my yearly version now. Now, see, when it is greater than 1.96, I have to reject the null hypothesis. Here, 1.696. Is it less than 1.96 or more than 1.96, madam?
Less than 1.96.
If it is less than 1.96, then we have to reject
Accept.
we have to accept the null hypothesis.
Yes.
What is the null hypothesis? There is no skewness. Yes or no, madam?
Yes, sir.
When we measure skewness, null hypothesis is there is no skewness. Okay, so now we accept the null hypothesis, which means no skewness. When there is no skewness,
There is a null hypothesis.
madam?
When there is no skewness,
Which means data is normal.
okay.
Clear? Hello?
Yes, sir.
Yeah, that's all. That's all matter of. Okay, so now this is one point. Another point, same thing now. Same thing. Okay, so now, okay, now let us look at our kurtosis, right? Now let us look at our kurtosis. Kurtosis is 0.491. Standard error is 0.360. Now let us go here. So 0.491 divided by 0.360, which is 1.36, which is again less than 1.96, which means null hypothesis accepted. Null hypothesis, there is no kurtosis. Okay, which is accepted, which means there is no kurtosis, which means data is normal. Hello?
Yes, sir.
Okay, so now, okay, so by looking at mere skewness, you should not give the answer. You have to calculate and you have to tell. So by looking at the distribution, we can find out whether it is normally distributed based on skewness, right? Two distribution, right? Based on skewness, we can tell whether it is normally distributed or positively skewed or negatively skewed. Based on kurtosis, whether it is normal or plateaukurtic or lepto. Lepto is leap. Leptokurtic and plateaukurtic. Okay, so we will see some more data and we will see how we can understand, right? We can understand. Okay, So now we will take some more data. So this is normally distributed, right? Okay. So now, okay, so we will have many more, right? We need to understand all, but not necessarily leave it. Okay. So, but I can teach everything, how it is calculated, all, how it is coming, what is the meaning. Everything is meaningful. Everything we can use very interestingly to write the interpretation. Okay. So now, age of the employer, right? So now instead of clicking every time, descriptive statistics, describing how the data, mean, median, how dispersed, how distributed. For one data we are doing describing. Okay. Now, see, we have descriptive statistics. We got explore, exploring, explore, right? We can explore, right? Okay, so then we can click this data and you need not tell anything, right? Plots. So we will see normal plots with the histogram. Okay, so now we can see here, I'm going to explain all now, right? Okay, so now we have a mean, we know that 42. We have a, what is the lower bound, upper bound, what is 5% trimmed mean, median 42, we have seen standard deviation 7, minimum 26, right? So do you remember, these are all the values, madam?
Yes, sir.
The values, right? Yes or no? Maximum 60, 26, 34, all, right? So all, whatever you are getting, you will get when you go for a explore. You need not click. All will be coming. So go to explore. Okay, all will come. So the skewness 0.307, standard error point. So cutoff is 0.491, cutoff is standard error. All will be there. So now there are some more new interesting things are there. Okay, so that also we will see. Right. Then, okay, so to derive whether the data is normal or not, this will come later. Now, this is the, okay, so this is the histogram. So histogram is the difference between bar chart. Bar chart is we will draw for a ordinal data or nominal data. So for this data, it will be continuously arranged. You can see. So when it is continuously arranged for a continuous data, okay, so it is the bar chart. So this is the histogram. So stem and leaf, okay, stem and leaf is, see, for example, right, if you know the data, you can understand, right? It started with the 26, right? So 20 to 30, right? 20 to 30, we have 26 to 2 26 are there. 128 is there. 429 age are there. From this, how I am. So 20 to 30, stem is 20. Leaves is 30, 0 to 9 leaves, 10 leaves are there. Okay, so each one leaf when or one case, so which means when I have 2 leaves, so which means 26 2, 28 1, this is 4, totally 7 are there in the range of 20 to 29. Then 30 to 39, okay, so 30 to 39. So this is also 2, it is divided into 2. 30 to 34 1, 35 to 39 1, divided into 2. So now 30, okay, so 4 30s are there, 31 3, the 2 this one is 33 4, right? Okay, like this. So like this we can see. Now when the stem and leaf plot, okay, madam, stem and leaf plot understood, madam? Hello? Madam, Nandri madam? பேச மாட்டாங்களே மேடம் சார் சிவகுமார் சார் இருக்கீங்களா இல்லையா ஹலோ
Yes sir, yes sir.
You are there sir?
Yes sir, yes sir.
Okay. So suddenly no voice is coming.
Nandini ma'am?
Sir, I am here.
Okay. So now, madam, understood this one, madam? This stem and leaf plot.
No, sir.
Can
I
you
didn't
see
get
the
it.
stem and leaf?
No,
Yes,
sir.
madam.
No, sir. I didn't get it, sir.
Madam.
Sorry, I'm very
the-
sorry.
Madam, 20 to 29. Age, right? What is the data, madam? Age, right, madam?
Yes, sir.
So some people will be 26, 21, 22, like that, right? Yes, sir,
Yes.
madam. It is a range data. It is a ratio data. Now, here, see here, madam. 20 to 30, right? 20 to 30. Now here 6. 2 means 20. 20 to 30. Because next 3 is coming. So 20 to 29.
Okay.
How many people are there? 7 people are there.
Okay.
In which 2 6 are there. Yes or no, madam?
Yes, sir. 2 6 are there.
Which means 26, 2 people are there.
Okay. 28 1.
28,
29 4. Now
that
I
is
got
what
it.
I was telling.
Okay, sir. Now I got it, sir.
So now here 30 to 34 it has arranged. Then 35 to 39 it has arranged. Now 30 how many? 4 people.
4.
31
31 3.
that's
32
all.
3. In that way. Okay.
That is the stem and leaf plot.
Okay.
Now, by looking at the stem and leaf plot, we can see by looking at the histogram, we can tell whether the data is normal, right? So when middle more, this one we can tell. So here also it is giving mean, here also it is giving standard deviation. So you have to remember the standard deviation is 7. So many times it will come. So now when the stem and leaf minimum is low, maximum is also low, middle is more, then it is normally distributed.
Okay.
So we have already proved it is normally distributed by looking at the skewness and kurtosis. Now again we are proving that with many plot. Okay. So that is why automatically I have not clicked this plot. Automatically all plots are coming. By looking at the histogram, we can tell. By looking at, see, this is a QQ plot. By looking at the, see here only the minimum age there is some deviation. All otherwise, all data is lying in this line. Okay, the expected line. So expected normal distribution. So the data is also going in the expected normal distribution. So it is a QQ plot. Now we will look at this is the box plot. Automatically it is coming, right? So this is the box plot we have drawn. Do you remember, madam?
Yes, sir.
So 60, 42, 36, right? 26, all right?
Yes, sir.
So automatically now it is coming, right? Very good. Okay. So now this is what okay. So how to find out the normality by using these skewness and kurtosis. Now, not at our okay. So many more interesting things are there. Okay. So now I will take up some more data where okay we can see some interesting things. Okay. Okay. So now it is a age, migrant age. So now, okay. So now I will go to the explore, right? Let me go to the explore.
Sir, screen is not visible.
Descriptive statistics.
Excuse me, sir.
Yes, madam.
Screen is not visible, sir.
New screen I have opened. That is why it will not come. I should not open any new screen. Then it will not come. So share this one entire screen. Why it is not coming? I do not know.
Now variance is visible, sir.
See, they are making changes which is disturbing us. See, every time earlier used to sell, don't share your entire screen, don't share your entire screen, it will be dangerous, something like that. We have never bothered about it. We are sharing the entire screen. Now they have removed that option itself. Okay, so now very good. Okay, so let it be.
Sir,
So
can we
they
go
may
for
take-
question time for 10 minutes, sir?
Yes, sir.
Can we move for 5 minutes for question time? Then
Huh?
conclude.
No, sir, we need to. Okay, I've taken my current age, madam. Hello, madam, my current age.
Sir.
Explore age. Okay, so plots. So I'm clicking normality plots with the test. The test also there. I'm not given the test. Hmm?
Okay, sir.
So that test also I will tell. Hmm? So now all values are there, madam.
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Okay. So first minimum, right? We will
Yes.
see minimum, right? Whether minimum is okay. It will not give frequency table. Okay. So minimum is what is minimum is so minimum. Okay. So
Eight.
then okay. So okay. So we will see the frequency table also. Huh? So minimum is 18. Yes or no, madam?
Yes, sir. Yes, sir.
Okay, minimum is 18. That is what it is telling.
Hmm.
Right? Minimum is 18. Maximum is 64. Right? You can tell maximum is 64. Right? Maximum is 64.
Yes.
Right? Then like that we can find out the okay. So the median is 31. Right? 50% 31. Right? So now. So 31 na?
Sir. 31 median.
Okay, now we will go and see minimum is okay 31. See here 50%. It has crossed 50. That is why it says a minimum median age is 50, right?
Hmm.
So now quartiles. Quartiles also we will see. Okay, what is quartile? So it is not given the quartiles, right? So now, but it is giving something more that I will touch. Now, okay, so the madam should tell what is Q1 and Q2. Tell Q1 and Q2, madam.
Sir, CSP, sir.
Q1, what is Q1? What is Q2? What is Q3?
Sir,
What is quartile 1, madam?
What? 25, sir. 25.
25, right.
27.
25, very good, madam. Right, 25. What is Q3, madam?
Q3 75, sir.
Hey, that is 75.
Sorry, that is 37, 75.
37.
37.
Okay, so Q3 is 37, right? Okay, hello? Q1 is 25. Q1 is 25, right?
Q1 is 25, yes, sir.
Yeah. Now, you know what is range? What is range, madam? Minimum minus maximum, right? So 64 minus 18. Yes or no, madam?
Yes, sir.
So the maximum is 64, minimum is 18. So now that is the range. Now we have interquartile range, IQR, interquartile range. What is interquartile range is range between two quartile, Q1 and Q3. Q3 is 37, Q1 is 25. What is interquartile range? 35, 37. Hello, 37 minus 25.
Okay.
Hello?
Yes, sir. Yes, sir.
What is that? 37 minus 25?
12.
12. Now you can see IQR is interesting. Okay.
Interquartile. Okay.
Interquartile range is 12.
12. Okay.
Okay, very good. So now you have to note it down. Okay, so we have to note it down. These values, right? What is interquartile range? And okay, so now one more interesting things I'm going to tell, right? Here you can see here, these two values are outliers. Now by looking at the box plot, we can already identify the outliers. These two are outliers. These two are outliers, right? So whether this side outlier or this side outlier, we can see. Okay, how the outlier is calculated? Okay, how outlier is calculated? Okay, so now okay, so how to remove the outlier? Okay, so that already 8 o'clock. Okay, so we will stop now. Okay, we will stop now. If you have any questions, I will take up.
Okay, sir. Sir, Kavita ma'am. 1 minute.
Kavita ma'am.
1 minute, 1 minute.
Yes, Kavita ma'am.
Yes, ma'am.
Yes, ma'am, please. Ask your question, ma'am.
Sir, actually, yesterday's session, I have missed the yesterday's session.
Yes,
So-
madam. Tell.
Okay, ma'am.
When I started to listen the today's session, I just want to have an overview on the yesterday's session, so I raised the hand. But sir, actually, the today's session I got understand, sir. No issues, sir. See, if
Okay,
possible, kindly share the yesterday's session video and today's session video. Then we could able to follow the tomorrow's session.
Madam. Okay, very good, madam. But you please attend every day, madam. Okay.
Thank you,
because,
sir.
every
With God's
day
grace today.
see.
God's grace today only. Now only I got link, sir.
Okay, madam. See, it is difficult to attend all the classes. Okay, but take some time out and please attend all. If I start teaching what we have happened yesterday, then I have to teach 100 days, right? Because the second day again, okay, difficult. Okay, but the first day is very important. Okay, so based on that only, so in future I will come, not today. Okay, future I will be using. Okay, very good, madam. So go through
Sir,
the
உங்க
video.
நேம் நான் கேட்டிருக்கேன். ஆனா நான் உங்க நேம் கேட்டிருக்கேன். இன்னைக்கு தான் நான் உங்களை பார்த்திருக்கேன், sir. Thank you for your session, sir. If possible, ask your coordinator to share the video, sir.
No, that is their prerogative, madam. Okay, so whatever they say, I don't have any objection, madam. Okay, okay. So now, okay, madam. That they will decide, madam.
Okay.
Now, Kailasapati.
Last question. Kumaresan.
Sir, good evening, sir.
Yes, sir. Yes, sir.
I'm very
Proceed, sir.
delighted to hear you. Sir, I'm
Kumaresan, please ask your
Yes,
question.
yes, sir. Thank you, sir. Sir, good evening, sir. I just want to know what is trimmed mean, sir. How will you calculate the trimmed mean?
No, here we have I have one data set also, sir. So for the same data which I am showing, no. So for employee data, employer, right? Migrant employee age, which I have done. So
Yes, sir.
I have trimmed data also I have, right? I can show here, for example, trimmed data. What is trimmed? If you look at this one, okay, so if you look at here, it will give trimmed mean. Okay, it will give a trimmed mean. Trimmed mean means, see, it is a 5% trimmed mean. Some people, they will be using 20% trimmed mean, 10% trimmed mean, like that. See, what is 5% trimmed mean is, so now we have a starting and end. So for example, here we have 900 data. Okay, so these migrant laborers. So you can see N is 900.
N is 180, no, sir?
Okay. Okay, so this is migrant. Okay, so this is 900, sir. Okay, so N is 900. Employer is 180, sir. Employer is 180. So now trimmed mean is 2.5% of the lower data. See, start from lower age to higher age, right? 2.5% of lower. So some in the lower side, and 2.5% at the higher side data, it is removed. After removing that 5% data, then if you find out mean, you will get that mean. That is called a trimmed. Data is removed. Data is trimmed. After trimming, what is
why
the
you are
mean?
removing that, sir?
I have not removed, sir. It is showing.
No, but why it should be removed, sir? Is there any particular reason, sir?
Yes, sir. See, why lower end, upper end? Lower and upper end is the outlier, sir. Possibility of outlier, sir.
But in this data, I think there is no outlier, sir. Because
No,
the mean is already 30. Mean is already
no,
31.
Sir, wait,
After
sir.
trimmed mean also there is
Sir,
31.38.
Sir,
Yes,
please
sir.
wait. Sir, if you do not want the trimmed mean, don't use it, sir. It is giving, sir. The software is giving. If you do not want to leave it, sir.
No, sir. Actually, if there is outlier, we can remove it. We can use it. When there is no outliers, it is not necessary, sir.
No, we have not removed, sir. It is removed and it is giving, sir. Right, okay. See, you have asked logic. That is why I am telling, sir. Right.
Fine.
See, now here, how do you say there is no outlier? Here I have told, here there is outlier, right? Here there is outlier. Two outliers are there. Right. So the idea is, right? See,
To remove the outliers.
we are not removing only outliers, sir. It is removing 2.5% of the data. It is a 5% trimmed mean. See, it is giving many output. It is up to you to use it. When there is a need, you can use it. When there is no need, there is no necessity to use it.
Fine, sir. Thanks a lot.
See, why they have done? So why they have done is, normally when you have a large size data, so the both higher end, lower end, there is a possibility of outliers, extreme values. Now let us not say outliers, extreme values, right? So if the extreme values are removed, how the mean is removed? Changing. See, when the extreme, when you look at the trimmed mean, so there is no much change between mean and trimmed mean, right? Which means there is no much extreme value. There is a small change. But when there is a big change between mean and trimmed mean, then we can come to a conclusion that there is a very large extreme values are there. Okay, so that is the inference we can derive by looking at the mean and trimmed mean. Hello?
Yes, sir. Yes, sir. I got it. Yes, sir. I am listening. You just carry on, sir.
Next. Any other questions, sir? Hello, 6 participants, they have raised hand.
Sir. First is Kailasapati, sir.
15 to 16 participant rises.
Sir, good evening, sir.
Kashiringam, sir.
Yes, sir.
Kashiringam, sir.
Sir, good evening, sir.
It's already many students waiting for the question. If we go with, I will collect the question and again.
Let it be last question, sir. Okay, fine. Final question.
Okay,
Sir, good evening, sir. Good evening, sir. Sir, out of the total demographic, what should be our total sample, sir? Sir, it means generally we used to take 100, 200, 600, 500 like that. So how should we decide on what basis we have to take the sample for respondents' response, sir?
That I am not touching, sir. The sample size determination is a 2-hour session, sir.
Yes, sir. Yes, sir.
That I have not discussed, sir.
Yes, sir, in the today's,
Participants, please ask.
sir, in
Participants, one request. Participants, please, one request is there. The sir is covering the data analysis from 0 to 100. So please ask the question related to the data analysis.
Wait, sir,
Please don't
Now,
ask
I will
your
tell,
question related to
No, no, no,
PhD.
no. Sir, Sivakumar, sir. Now I will tell, sir. See, sample size.
Okay.
What is the appropriate sample size? How to decide the sample size? That is a separate discussion, sir. That I have not touched. I cannot teach within 1 minute, sir. I cannot tell in a hypothetical way, sir. It should
Yes.
be calculated in a scientific way, sir.
yes.
Next, sir. Okay, so I think we will
Nandini
stop
ma'am?
with this.
Sir.
Conclude.
Yes, sir.
Same 5:45.
Okay, sir. Okay, sir. So it's given me immense pleasure to propose today's vote of thanks on behalf of Seshadripuram Academy of Business Studies and on behalf of Seshadripuram Educational Trust. First, I would like to thank our resource person, Dr. R. Kasilingam, sir, Professor Pondicherry.
Madam, every day you need not thank madam. You please
Thank you,
describe
sir.
what we have discussed, 1 or 2 points, and you can say
Um,
thanks to everybody. Yes, madam.
Yes, sir.
Hmm.
So today's analysis part, we learned from a mean, how to calculate mean, how to analysis through the mean, especially the ratio data as well as for the interval data. We learned that. Thank you, sir. Thank you for that. And I also thank Jairam, sir, Principal, Seshadripuram Academy
No,
of
no,
Business.
that is only 5 minutes we have discussed, madam. We have discussed about measures of Okay, madam. Okay.
So I also thank our research coordinator, Shivkumar, sir. And also last but not least, I would like to thank all the participants for joining for today's session. We also look forward your active participation throughout the entire another 8 days of FDP. Thank you, everyone.
Thank you, madam. Thank you, sir. Thank you all.
Thank you, sir. Thank you, sir. Thank you.